Hello, everyone. Hopefully you can hear me. It's a pleasure to be here, and we'll jump right in with the observation that scientists have long warned of a rush of new infectious diseases emerging out of food landscapes. The millions killed by COVID-19 this past year underscored that warning as more than just academic. In the next half an hour, Rob Wallace and I will explore the impacts of agribusiness and finance capital on infectious disease. Next slide. We start not in 2019 or even the year 2000, but farther back, much farther, as proposing means by which to exit our present epidemiological trap requires we discuss how we fell into it to begin with. Much of what we know as nature is in reality a series of large food forests that were locally adapted by indigenous groups across multiple continents, from hunting and gathering to the origins of agriculture and beyond. Here in this picture is a modern holdout outside a village in Morocco that dates back before Christ. It hosts bananas, oranges, dates, guavas, lemons, mulberries, olives, and chickens feeding in the undergrowth. Next slide. Such forests are no natural order. They're emblematic of a human history that continues on today. The modern clash between agricultures that conventional on one hand and agroecological production on the other represent began early in the age of European conquest. Food production was tied to questions of power and ownership right from the start. As described by a variety of scholars, from Guyanese political economist and anti-colonial revolutionary Walter Rodney to geographer Jason Moore and beyond, the landscapes and peoples Europeans newly encountered were decoded by modern science and then recoded for expropriation and commodity export. Next slide. For instance, as described in Cedric Robinson's 1983 text, Black Marxism, a triangular economy linked New England, small farmers and fisher people, the Caribbean plantation owners and enslaved workers, and Western European merchants and industrialists. Financiers bought and sold slaves, providing the labor power for the production of raw materials in the Caribbean, which were then shipped back to Europe as the raw materials for industrial manufacturing. Whereas the plantation invented new technologies of racial and colonial domination that would be used time and again in the spread of capitalism, the small farmers and fisher folk of the New England colonies, still a sort of agrarian model and imaginary for many, were buoyed by newfound markets for produce and salted fish in the Caribbean, where European plantation owners fed these cheap food stocks to enslaved Africans. So I want to point this out, this sort of triangular economy out, because ours today is a historical present that retraces and remakes many of these very same routes of finance, racialization, and food commoditization that still undergird global capitalism. Next slide. Clashes over the nature of agriculture have been ongoing with the industrialization of production all along, whether in the countless uprisings in the slave plantations or labor strikes and disputes in the European core. Machinery and other technologies were installed as more than mere automation, but for capturing control of decision-making around food production. Environmental sociologist John Bellamy Foster describes the early opposition to such production, including, yes, to a certain type of mechanization, but also against land enclosure, agricultural pollution, poisonous food alteration, deteriorating animal welfare, and reductions in locally available food for the emerging urban underclass. So rather than positing agroecological alternatives as taking place outside of or even coexisting with industrial agriculture, which is the often sort of popularized, non-confrontational norm, tracing these histories helps us to think about a militant and oppositional agroecology, where the creation of alternatives is inseparable from eliminating the social and technological production peculiar to capitalism. Next slide. Otherwise, in the name of freedom of choice, we are left accepting the box agribusiness has placed us in, as if such a thing had anything to do with choice for much of the world. By state force and economic compulsion, capital has rationalized agriculture, capturing and privatizing much of its natural conditions and externalizing the damage to a supposed outside ecology. In tracing how the evolution of infectious diseases, one mode of such damage, at both the molecular scale and the global scale of industrial agriculture are actually two sides of the same coin, we can think through how capital processes reduce and expand the scales at which accumulation and its afterlives of pollution and externalities take place. The smaller and larger began to be combined in the 1930s. Seed privatization created uniform hybrids, concurrently with the expansion of larger agricultural machinery to farm more acres with less labor. As we see in the image of the Chicago stockyards above, a mixture of scientific feeding regimens, veterinary medicine, and logistical technologies, combined with industrial chemical manufacturing, facilitated the rapid expansion of large-scale meat production. Next slide. Today, companies such as China's privately owned Guangxi Zhangjiang company continues the trend, adding to its 2 7-story sow breeding operations, a 13-story hog hotel in which to raise 1,000 head per floor. Bayer champions digitized molecular genetic tools to privatize beneficial soil microbial communities, while at the same time developing satellite GPS systems that allow tractors to crawl over thousands and thousands of acres without a human operator. This dual movement of capital and science extracts out the world and agribusiness's image. It replaces the ecologies upon which food and people depend. It propagates those losses in compounding externalities of runaway carbon emissions, forced removal of smallholder farmers, myriad inputs that rob farmer revenue, extreme labor exploitation based on white supremacist racial hierarchies, pollution, and the virulent infectious diseases we'll be talking about today. Next slide. So what is the more proximate framework out of which such diseases emerge? Capitalist industrialization and privatizing surplus value have effectively transformed planet Earth into planet farm. In this slide, we see the resulting imbalance in biomass in millions of tons for, from left to right, vertebrate wildlife, livestock, and people. Next. And here are the geographical distributions to show for it. This is an oversimplification as we're combining very different livestock, but here are the total livestock per square kilometer, including all cattle, chickens, ducks, pigs, sheep, and goats. Next slide. We see an attendant explosion in global intensification in meat production. So here we see the relative output to input for chicken, cattle, and pork. Next slide. Driven by the global spread of the vertical integration by which all the nodes, or almost all nodes, of animal production are placed under one company's roof, from fertilization to meat packing. Here we see the consolidation in US hog farms, with the number of farms precipitously declining and the average heads per farm exploding. Fewer farms, more meat. Next slide. The consolidation in physical space goes hand in hoof with that in ownership. A declining number of meat companies in the US and elsewhere have parlayed vertical integration and reversals in antitrust law into mass consolidation into some of the greatest monopolistic livestock concentrations in the world. Next slide. The agroeconomic transition can be felt globally with, here, annual global production in pigs more than doubling in 50 years and international exports in gray nearly tripling the last decade. Next slide. It isn't just the size and expansive geography of the system. It's also about time and even the nature of life itself. By a modern futures market of 19th century origins, livestock and crops began to become financialized, alive. Organisms are now committed to fungibilities months before their actual births or germination. These commitments extend beyond their mere identities as commodities on the trading floor, all by computer at this point. Species are treated as asset classes subject to price volatilities that are respected as realer than the ecological dynamics into which the actual animals will be born or planted months hence. As a result, breeding, birth, and development are logistically bent to servicing these market projections first. Next slide. Poultry thyroids, another example, have been selected for failing to recognize when stomachs are full. As a result, broilers are meeting their much larger target weights, a 400% increase since the late 1950s in only 6 weeks' time. The meat is added on so fast that poultry suffer musculoskeletal morbidity and psychopathologies that include stress pecking associated with growing so much meat on so many thousands of birds bunched together. The population densities help select for increasing pathogen deadliness as well. We'll talk about that more in due course. But to the present point about putting finances before the very animalness of the creatures involved, efforts to prevent such outbreaks are now organized around circumventing birth itself. Specific pathogen-free offspring aren't born, they're built. Next slide. Sows that are on the cusp of farrowing are euthanized en masse before or after delivery by terminal hysterectomy. Their uteri are removed and placed in humidicribs or doused in antiseptic before the piglets are removed from their uterus casing. Piglets are then isolated and some medically induced into early weaning. So living fungibilities here. We're talking about the extreme lengths taken to avoid changing the very business model that selects for many of these pathogens to begin with. Next. Planet Farm, growing more and more food, is neither necessary nor a good idea. What is imposed on the individual animal or herd is recapitulated on greater ecologies. In an economic system dedicated to 3% compound growth, better and cheaper extraction, increasing efficiency per unit currency invested, selects for greater exploitation, often until a resource is exhausted. Under the present economic model, the paradox is solved only by exploiting an alternate resource once the original is depleted, wiping out the natural base, species by species, mineral by mineral, region by region. Next slide. And that includes expanding out and commoditizing what was previously only part of a subsistence diet. Running alongside the decrease in diversity per livestock species, there's now an attendant domain switch in the commoditization of wild foods. The taxonomy is extraordinary. So ostriches are now farmed. Next. The Southeast Asian porcupine. Next. Crocodiles. Next. Fruit bats. Next. The Asian palm civet, whose partially digested berries now supply the world's most expensive coffee bean at $1,000 per kilogram. Next. And some wild species are making it onto forks before they're even scientifically identified, including this new short-nosed dogfish found in a Taiwanese market. Next. This isn't really a matter of fear-mongering or of runaway markets. Under neoliberalism, the states of the global north and the sub-imperiums farther south organize such haphazard expropriation by, for instance, expanding genetically modified seeds into African markets under the guise of food security. Next. Or expanding how insurance markets can target small farmers, as in this case of Swiss Reinsurance Corporation underwriting the Nigerian Leadway Assurance Corporation's movement into agricultural risk management, privatizing what would otherwise be public support for smallholder agriculture. Next. Altogether, such efforts comprise global systems of accumulation. The world circuits of capital are deeply embedded into husbandry and land use in ways that extend out beyond just agricultural production. Here we have the percent of land whose harvests are consumed abroad as agricultural goods, those are in green, but also indirectly, say as in feeding workers or supplying inputs for manufactured goods and services, in blue. And we have them mapped for, from left to right, croplands, pasture lands, and forests. And then their sort of aggregate combination in the bottom. So landscapes themselves are globalized, next, by circuits of capital, with capital accumulation in countries other than the countries sourcing the natural resources in red on top, and consumption abroad on the bottom, across croplands, pasture lands, and forests. So production and consumption are sort of disaggregated and sort of separated and connected by these sort of broad circuits of capital. As Rob will explain, from such a vantage point, basic assumptions of epidemiological causality at the heart of even steps forward, like One Health, which is attempting to integrate studies of wildlife, livestock, and human health, may be reversed.
Yeah, yes, thank you. Next slide, please. So that's right. Reversals in our understanding become a fact of life. So let's take H5N1, which clearly emerged in the southern Chinese province of Guangdong in 1996, before spilling over into nearby Hong Kong. Can you click, please? When we include what we've learned about the economic relationship Hong Kong and Guangdong share, causality shifts in the other direction. So by the 1990s, the relationship had returned to pre-revolutionary dynamics, whereby Hong Kong acts as a proverbial front of the store, providing capital and marketing for Guangdong, which is the back of the store where production takes place. Can you click, please? Indeed, at the time of H5N1's emergence there, and by the way, SARS-1 emerged out of Guangdong as well, 4/5 of foreign direct investment through Hong Kong went to Guangdong, including, can you click, please? Backing the kind of shifts in agricultural and land use implicated in disease emergence. So contrary to the morality tale that repeatedly characterized Hong Kong as some innocent victim, Hong Kong appears as responsible as Guangdong for H5N1, and causality, can you click, please? Moves in the other direction as well. Next slide, please. In this way, the source of a new disease may not be merely the country in which it first appears. It may extend as far as the other side of the world. We need to identify who funded the development and deforestation to begin with. And it begs whether we might more accurately characterize such places as New York, London, and Hong Kong, which are key sources of capital, as disease hotspots in their own right. Next slide, please. So all these structural demands are borne out on the ecologies of poultry and livestock, both inside and outside the barn. The focus of our more structural One Health, focusing on these bigger picture things, not just on loss of forest. The structural more health, we've been focusing more on this livestock revolutions, the effects of that livestock revolution, the more corporatization of livestock and poultry, what the effects of that has been on the epidemiology of pathogens circulating in such environments, their evolution, their spread, and spillover into human populations. Next slide, please. Big picture, the rate of new disease emergence has picked up through the turn of the century across outbreaks, kinds of disease, host type, pathogen taxonomy, and transition mode. All with the neoliberal term in agriculture worldwide, so 1980 on. Next slide, please. COVID-19's emergence appears correlated with China's own self-exploitation under a BRICS capitalist model that moved millions out of poverty, if at the expense of the kind of agro-epizootic resilience. So here we see the land use change in the Lake Dianchi watershed in Yunnan province, where a lot of people think the different SARS have emerged. And this is from 1974 to 2008, and you can see the development really accelerating. Next slide, please. The subsequent land pressure comes up against what since SARS-1 in 2002 has been documented as a wide variety of SARS-like coronaviruses circulating over many species of bats across South and Central China, including Yunnan. Next slide, please. Now, it isn't merely a matter of the spatial nature of that encroachment. The wild food sector we described, Alex described earlier, has been increasingly capitalized in China by some of the same financing that backs traditional industrial livestock. So we have this classic dichotomy between wild foods and livestock that seems to be falling away as an economic sector, but also the two sectors, wild foods and traditional livestock, share kind of an expansive geographic spread into the last of forests as they compete for or overlap in their land use. So we can have a mosaic of sectors clustered together. So we have traditional livestock, we have wild food farming there at the top left, we have bat guano farming down at the bottom left, and that altogether will increase the likelihood of disease spillover. So Sarah Olson's group here showed on the right there that increasing in coronavirus prevalence, the coronavirus prevalence increases along further along you go on this South Vietnamese food chain. So from wild food farms on the forest edge to the town market, all the way to the restaurant table. You have an increasing prevalence of coronavirus, and the exposure is compounded across this peri-urban circuit that capitalization built. Next slide, please. So such intrusive production is equivalent of insisting on interrupting a bar fight. So if you're in a bar and you see two people start fighting, you don't want to interject yourself. You want to back out of the bar. But we insist on interjecting ourselves because the coronaviruses and the bats are in an evolutionary arms race, and they've been producing SARS-like strains, a variety of infectivities for both bats and humans. And so some, I don't know if you can see that in the bottom right there, some of these new infections are supporting human infection, and some of these new SARS are not supporting human infection. But the point is that we are engaged in a kind of roulette wheel that we're spinning here, and round after round, we have these new coronaviruses emerging, and any one of them are possible to go pandemic. Next slide, please. And as I said, any one of them can go pandemic. Any one of them can figure out the immune system, and they can tap a domestic travel load in China that has increased tenfold just since the SARS-1 epidemic. That's not only for China, worldwide, a lot more trade and travel. Next slide, please. And diseases, these new diseases appear to be combining in their impacts. So in a recent preprint, Xiao and colleagues proposed that the industrial African swine fever outbreak that started in 2018, in which many of us were looking at as being the next pandemic then, that African swine fever apparently cut into the domestic hog supply that was available in China. As you can see across the top there, those maps on the top line there shows the impact on hog. And that may have increased hog price and volatility. Those are the two middle maps on the side there. And then that may have driven an increase in the incursions upon bat populations. And that is represented in part there in the bottom right there with the amount of new freeway that was laid down, and in the red there is Yunnan. So you have an incursion into more wild forest areas. So that's it's a possibility. The problem is that's that it presumes that SARS-2, the virus that causes COVID-19, emerged in 2019, and the evolutionary genomics modeling actually places SARS-2 in human populations many years before. So it doesn't really support that hypothesis. But the key point still stands, I think, and that with multiple pandemic pathogens emerging in parallel, the socio-ecological combinations driving disease emergence may be increasing. Next slide, please. So despite the white heat on the debate about COVID's origins, we're still in early days yet. This is only about 15 months out, so there's plenty more work to do. So the specifics relating industrial structure to disease spread and evolution have been much better documented in other pathogens. So I'm going to talk a little bit about H5N1, and that was the deadly avian influenza that emerged in 2016, which decimated poultry across Europe, Asia, and the Middle East. And the epidemic, moving across Eurasia in wave after wave, followed an eruption of H5N2 here in the US Midwest in 2015. So clearly the dynamics we're describing here aren't just a China thing, it's everywhere. Next slide, please. Given our limited time, I'm not going to go into all the details here, but I will stop by a variety of sciences that have characterized these new influenzas. So here we have ecologist Marius Gilbert's group showing that H5N1 represented a shift in influenza's environmental niche from hitting areas of extensive chicken production, which is characteristic of mostly smallholder populations, to areas of intensive chicken production, urbanized human populations, and managed horticulture. And this means that the new strains appear increasingly adapted to industrial poultry production near urban centers. Next slide, please. H5N1's rise isn't just a matter of shift in where the virus is spreading. The new strains are also evolving new attributes fit for infecting poultry. And in a world of COVID variants, I think you get the sense of what that means. So here we see the evolution in hemagglutinin. That's the H of H5 that the influenza virus uses to key into host cells. Well, if you can click it, please. H5N1 on the right there, it's switched its binding specifically to receptors in waterfowl intestines. It went from that to also expanding to hitting receptors found in poultry throats. And what that means is the virus is able to infect a broader range of host species, now including the poultry global agribusiness raises in the billions. Next slide, please. The virulence or the deadliness of avian influenza is connected to modes of production. So here we have a map, 1959 to 2015, of all documented conversions in H5 and H7 strains from low deadliness to high deadliness. And all these happened, save a couple of them, they occurred on large-scale operations of more than 10,000 poultry. And the mechanism is that the more food for fluid available, the deadlier the strains that are going to win out, that are going to be selected for. Next slide, please. The phylogenetic evidence has rolled in as well, with H5N1 undergoing a population increase, a burst in diversity, only when the virus entered populations of domestic poultry in China. And that's a result that's reproduced on the right there at the genomic level. The influenza genome is segmented, and they trade their genome pieces like card players on a Saturday night. And we can see that the different flus traded these segments into virulence, but that only occurred when H5N1 entered domestic population. That's only when it really engendered the worst of deadliness. Next slide, please. There's a series of seroepidemiological studies of workers, taking blood samples, seeing who's infected with what, and they show that multiple influenza types widespread across the Chinese poultry chain supply there. Next slide, please. Much of the diversity of influenzas found in wild waterfowl, which is the fuel for new strains, is now also found at industrial sites. So it's not merely a matter of blaming wild waterfowl. Agribusiness is in essence its own virus source at this point. So one research group tracked the various H1, H3 subtypes moving through industrial Hong Kong swine, including classical swine influenza, Eurasian swine flu, the triple reassortant swine flu, H1N1, 2009, seasonal H1N1, H3N2, and on and on. Next slide, please. And we see with hemagglutinin across the top and neuraminidase, that's the N in the H5N1. The neuraminidase is a different protein, and we can see them, that there's a similar increase in the richness in influenzas that industrial poultry are supporting. And you can see that all in the red there are examples of where combinations of these hemagglutinin and neuraminidase that are now industrial production. Next slide, please. And it's a richness that's found also spilling over into humans now. So it used to be we were just hit by the H1s, H2s, and 3s, and now we're hit by the H5, 6, 7s, and 9s. China just announced that an H10 is the first to be able to infect humans the other day. So this continues, and that doesn't bode well for pandemic planning, as we have little to no standing herd immunities to these new reassortants. So indeed, even our H1s aren't grandpa's H1. Next slide, please. We have the increasing diversification of swine and avian influenzas are arising from this expanding geographic extent of these livestock commodity chains. So every one of swine flu H1N1's genetic segments here proved most closely related to those of influenza circulating among swine, and they were together originating on wholly different continents, right? Some segments from Eurasia, some from North America. How do they get together? Well, the geographic extent in the commodity chain is something that no smallholder operation it deals with. It's the large companies that do that. Next slide, please. Martha Nelson's team better inferred that dynamic. They showed spatial jumps from country to country as counted through all the swine influenza evolutionary trees, all the genomic segments, all lineages from one location to the other. I know I'm getting a little bit into the scientific weeds here, but I find this result fascinating. And what they show here is that unlike for poultry, for hog, China, unlike for poultry, for hog in China, in the bottom half there, as far as the countries of origin for these hog influenzas, China is not an important source of swine influenzas on the global stage, as most of its hog at this time were purchased domestically. The US, on the other hand, the leading global exporter of hog, is also the leading global exporter of swine flu. Next slide, please. By the same technique, the team did a follow-up study tracking the migration events for swine flu H1N1. And back in 2009, our group named swine flu H1N1 the NAFTA flu after the 1994 North American Free Trade Agreement, when barriers to hog exports, among other commodities, were taken down, and it was permitting companies like Smithfield to ship hogs into Mexico and set up intensive piggeries down there too. And it appears like our group calling it NAFTA flu, we weren't just being provocative. The notion of a NAFTA flu is now backed by evidence found in the genetics of the virus. So we see here with the US and Canada seeding multiple flu segments in Mexican states with the greatest hog concentrations, and led to the emergence of the last pandemic we had, the swine flu H1N1. Next slide, please. Consolidation, globalization in the poultry sector affects evolution and spread of influenzas in other ways. So we have nearly 3/4 of the world's poultry breeding is in the hands of a few multinationals. For instance, the 10 companies that were producing egg layers in 1989 were consolidated to 2 by 2006. So we have the Germany-based ARERC Johann Group and Hendrix Genetics. The consolidation doesn't just reduce poultry genetic variation. The industrial cascade from primary to multiplier breeders with all the breeding conducted offshore. What that does is it removes natural selection as a free ecological service. And what that means is that any culling that a farmer might do on site when there's an outbreak, under an industrial model that has no impact on the development of immune resistance in their herd or their flock. The animals aren't able to reproduce on site, and they don't evolve in response. So in other words, the failure to accumulate natural resistance to circulating pathogens is built into the industrial model before a single outbreak occurs. Next slide, please. So we have a variety of mechanisms by which influenzas prosper from the very model of production. And yet these are left largely in place by agribusiness. Why? How do they get away with that? Well, for decades, agribusiness understood the damage incurred by such production, the infectious diseases, the stress pecking, all that, and they ended up offloading growing out production onto contract farmers who take on all the risk but have no control over production practices. So the companies are using contract farmers and their accumulated debt as kind of a trap crop by which to sop up the costs of such dysfunctional production. And that setup worked beautifully during the H5N2 outbreak here in the United States a couple of years ago. Contract farmers absorbed the losses of birds killed by the virus. The federal taxpayer paid for the birds culled after the outbreaks began. So it's a kind of an epidemiological circuit breaker, and it worked for the company as they designed it. And what that does is that allows influenzas and other pathogens to continue to spread because the companies offload the economic consequences onto everybody else. Next slide, please. So what to do? And Alex is going to finish our talk today. He's going to take us through a brief pass of possible alternatives.
Yes. So we imagine Tammy Jonas will speak more to some of these specifics tomorrow. But briefly, moving agriculture back into its ecological matrix will do more to protect humanity from new pathogens than industrial agriculture's continued alienation. Reintroducing agrobiodiversities on farm and across regional food landscapes will produce the immune fire breaks that keep the most virulent pathogens from ramping up and spreading. Allowing livestock and poultry to reproduce on site, as in the upper right photograph, would reintroduce natural selection as a way operations can track resistance to a circulating pathogen in real time. But such a probiotic ecology can succeed only if it's linked to farmer autonomy, community socioeconomic resilience, circular economies, community land trusts, integrated cooperative supply networks, food justice, reparations, and reversing deeply historical race, class, and gendered traumas. Efforts such as Brazil's Belo Horizonte food system on the upper left, Soul Fire Farm in upstate New York in the US, lower left, and the Federation of Unions of Farmers Groups of Niger on the lower right, represent these modes of expansive systemic change linking socio-ecologies that we argue are the key to stopping the worst of infectious disease. There's a catch, however. Healing the metabolic rift between ecology and economy, driving the disease and climatic damage at the heart of modern agriculture, involves imprinting a different political philosophy upon the landscape far beyond green capitalism. Revolutionary transformations are needed, or these agroecological efforts, even up to the scale of regional food systems, will no more than patch together industrial agriculture's violent contradictions. So much work, next slide. So much work remains, of course, from specific programs and tests in the next 5 years to the generational project of changing our mode of social reproduction. In the immediate and with adequate funding, our team is prepared to pursue a unified theory of disease emergence that integrates the impacts of latifundia and industrial production upon the evolution and spread of pathogens across taxa and place. We'll be able to trace multiple skeins of cause and effect in and out of molecular biology, disease ecology, evolution, political economy, and the kinds of landscape agriculture shown here. We would be able to offer models of regional planning and a full array of modes of intervention from on-farm to state programs and relational geographies from one side of the world to the other that would altogether embody a likely exit out of the worst of our present disease trap. Next slide. All of which, however efficacious, will depend on the nature of power extending well beyond our team or any researcher's domain. As history has shown us, which decisions are to be enacted, where and by whom depends on the wider world. That's all your fundamental contribution to this generational project. For we won't be able to technocrat our way through COVID-21, 22, or 23. It's more of a system problem than that of any individual virus. Next slide. And with that, we just like to thank you all very much for having us and look forward to some discussion.